Hyperconjugation. This is today's lesson. Hyperconjugation is a kind of resonance that involves sigma bonded electrons. Resonance that occurs with the participation of sigma bonded electrons is hyperconjugation. Hyperconjugation happens with the participation of sigma bonded electrons. In this lesson, we are going to learn definition of hyperconjugation, examples of hyperconjugation, hyperconjugation in toluene, and finally, role of methyl group in toluene as effect of hyperconjugation. So, let's begin. The first point is definition of hyperconjugation. Let's see. This is acetonitrile. In this molecule, this carbon-nitrogen bond in which there is reason to occur resonance structures. Here, what is that reason? Here, electronegativity of nitrogen is 3.1, carbon is 2.5. This is quite a high difference in electronegativity. Because of the higher electronegativity of nitrogen, these pi bonded electrons move towards nitrogen, and as a consequence, over nitrogen negative charge develops. At the same time, over carbon positive charge develops. Because of this positive charge, to diminish this positive charge, these sigma bonded electrons of carbon hydrogen bond move towards carbon-carbon bond. As a consequence, we get another resonance structure, that is hydrogen, carbon, hydrogen. Here, carbon-carbon single bond turns into carbon-carbon double bond, and then carbon nitrogen triple bond turns into carbon nitrogen double bond. Over nitrogen negative charge, but this positive charge over carbon shifts to hydrogen atom. Hydrogen atom with positive charge, these sigma bonded electrons move to carbon-carbon bond. So here, sigma bonded electrons participate in resonance structure formation, and as a result, we get another resonance structure of acetonitrile. Here, again, because of this positive charge, these electrons, lone pair of electrons, turn into bond pair. Again, these bond pair electrons turn into sigma bond between hydrogen and carbon, and acetonitrile forms two resonance structures in which no bond remains between this carbon and hydrogen. That is why hyperconjugation, sometimes called no bond resonance or bondless resonance, because here resonance structures are obtained. In this case, no bond is present. Resonance hybrid can be written as in this way: hydrogen, carbon, hydrogen, carbon, double bond, nitrogen. Here, this is one bond. This is resonance hybrid of acetonitrile. In this case, in the formation of resonance structures, sigma bonded electrons participate here. So, definition of hyperconjugation is delocalization of electrons with the participation of sigma bonded electrons that stabilizes the molecule. Is called hyperconjugation. Let's see resonance hybrid of acetonitrile accurately. Over nitrogen partially negatively charged and over hydrogen partially positive charge. This is resonance hybrid of acetonitrile accurately, that is produced for hyperconjugation effect. Let's see some examples of hyperconjugation. Let's see hyperconjugation in nitromethane. This is nitromethane. Here, nitrogen oxygen bond. This bond is coordinate covalent bond, which is denoted by arrow. Hyperconjugation is produced because in nitro group the reason is here. In nitro group, electronegativity of oxygen is 3.5, nitrogen is 3.1. Because of the difference in electronegativity between nitrogen and oxygen, these pi bonded electrons move towards oxygen, and over oxygen negative charge develops. At the same time, over nitrogen positive charge develops. Because of this positive charge, sigma bonded electrons of carbon hydrogen bond shift to carbon nitrogen bond, and positive charge shifts to hydrogen. As a consequence, we get resonance structure of nitromethane like this: hydrogen, carbon, hydrogen. Here proton with no bond, carbon nitrogen double bond is formed. This is single bond, this is negatively charged. Here coordinate covalent bond. In this molecule, because of this positive charge proton, this electron pair turns into covalent bond. This covalent bond turns into again sigma bond, and as a result we will get this compound again. That means these two compounds are resonance structures of nitromethane. Resonance hybrid is hydrogen carbon hydrogen. Here hydrogen with partially positive charge, carbon nitrogen bond, oxygen with partially negative charge, nitrogen oxygen coordinate covalent bond. This is resonance hybrid of nitromethane, which is formed for the effect of hyperconjugation. Let's see another example. Now, ethyl carbocation. Let's write hydrogen, carbon hydrogen, hydrogen, hydrogen. This is positive charge, ethyl carbocation. Because of this positive charge, these sigma bonded electrons move to carbon-carbon bond, and this positive charge shifts to hydrogen, and as a result we get another resonance structure of ethyl carbocation in this way. Proton with no bond with carbon, and here carbon carbon double bond, hydrogen, here hydrogen. Because of this positive charge proton, this covalent bond again turn into sigma bond between hydrogen and carbon, and this positive charge shifts over carbon in this way, and as a result we will get this ion again. That means these two structures are resonance structures of ethyl carbocation of the effect of hyperconjugation. Resonance hybrid can be written as hydrogen, carbon, hydrogen, hydrogen with partially positive charge, carbon, hydrogen, hydrogen. This carbon with partially positive charge. That is, this partially positive charge and this partially positive charge form a complete charge. That is why here both the atoms carry partially positive charge, and this is the resonance hybrid of ethyl carbocation which is formed of the effect of hyperconjugation. Let's move on to the next point. Now the point is hyperconjugation in toluene. Let's write formula of toluene first. This is toluene. We know that this benzene ring, that is in benzene ring, these pi bonds continuously change their positions. That is, these pi bonded electrons move continuously inside the benzene ring. Because of the continuous movement, phenyl group achieves electron withdrawing nature. Because of this nature, hyperconjugation happens in toluene. Because of the electron withdrawing nature of phenyl group. Because of this electron withdrawing nature, these covalently bonded sigma electrons move here to carbon-carbon bond, and at that time these pi bonded electrons move to this carbon, and as a result we get this entity, carbon-carbon double bond, carbon, hydrogen, hydrogen, here proton with no bond, and these pi bonded electrons turn into lone pair electrons, here double bond, here double bond. Again these electron pairs form pi bond. This pi bond turns into electron pair, and we get this one, carbon, hydrogen, here hydrogen, hydrogen with no bond, here double bond, here double bond, this double bond, and here electron pair. Again we get these electron pair form covalent bond. These covalent bonded electrons turn into lone pair electrons, and we get hydrogen, hydrogen, here hydrogen with no bond, here double bond, here double bond, here electron pair. Again we get this lone pair will form covalent bond. This covalent bond will again turn into sigma bond between carbon and this hydrogen. Then we get here double bond, here this double bond, and this carbon carbon double bond will turn into single bond. Again, sigma bond is formed between this carbon and hydrogen, this hydrogen and this hydrogen. In this way, resonance structures are obtained of toluene for the effect of hyperconjugation. In toluene, hyperconjugation occurs because of the phenyl group. Phenyl group is electron withdrawing group. That is why this carbon hydrogen sigma bond participates in resonance structures formation. So this is hyperconjugation in toluene. Let's write hybrid structure of toluene for the effect of hyperconjugation. Hydrogen with partially positive charge, here hydrogen, here hydrogen. We can put this ring in this way. This position, that is ortho position, will be partially negatively charged, ortho position. Then para position will be partially negatively charged, and then again ortho position will be partially negatively charged. This is resonance hybrid of toluene for the effect of hyperconjugation. Let's move on to the next point. Now the point is role of methyl group in toluene. Let's see. This is benzene. Each carbon carries one hydrogen atom each. In this way. Benzene ring is electronically dense place, electronically rich compound. That is why benzene ring is attracted by electrophile. Electrophile attacks any carbon of the benzene ring, and as a result this hydrogen gets freed as electrophile. That is, here this is obtained. Electrophile plus proton. That is, benzene basically undergoes electrophilic substitution reaction. Electrophile combines with benzene and this hydrogen gets freed as electrophile. Electrophilic substitution occurs. But how methyl group affects this benzene ring? Let's see. This methyl group pushes electrons through hyperconjugation. As a result, these ortho positions and para position become electronically rich because of the electron donating nature of methyl group through hyperconjugation in toluene. As a result, electrophile get chance to attack ortho position and para position. That is, methyl group increases electron density in benzene ring. As a result, electrophile can attack benzene ring easily. That is, simply methyl group increases electron density in benzene ring. That means methyl group activates benzene ring towards electrophile. So it can be said that methyl group is a kind of benzene ring activating group. Again, this methyl group increases electron density at ortho positions and para position. As a result, electrophile attacks easily ortho positions and para position, not meta position. So we can say that methyl group in toluene is ortho-para directing group towards electrophile. So methyl group number 1, benzene ring activating group. Number 2, methyl group ortho-para directing group. This is all about role of methyl group in toluene, benzene ring activating group and ortho-para directing group towards electrophile. This is all about hyperconjugation. Number today, thank you very much.